Hi, Nicole. You mentioned that you was having trouble with 53 in section 2.6, so I thought I'd make a quick little video of it here for you. Um, we know in this problem that, just as you said in the email, we're looking for vertical asymptotes when the denominator is 0, so that x squared minus 1 is 0. So that's going to give us vertical asymptotes when x minus 1 times x plus 1 is equal to 0, factoring difference of squares, which that gives us our vertical asymptotes at positive and negative 1. Now, I know you mentioned you had that, I believe. Now, our our horizontal asymptotes, since the degree of the numerator and denominator is the same, the horizontal asymptote is just going to be the fraction of the leading coefficients, which would be 2 over 1, or just y equals 2. Now, the x-intercept, set your numerator equal to 0. Say, well, we're going to have an x-intercept whenever 2x squared equals 0. That's going to give me an x-intercept when x is 0. So now I have that. Y-intercept, that's going to be f of 0. And f of 0, again, is going to give us 0, because I get 2 times 0 squared over a negative 1, so 0. So my x-intercept and y-intercept is at 0. So I should be able to graph this in here. Let's see. I know that the vertical asymptotes are going to be at positive and negative 1. So I'll say negative 1 here. And positive 1, that right here, has a horizontal asymptote at 2. Okay, now, when I try to graph this out, I can say, well, all right, I have the asymptotes drawn in, and I'd like to be able to plot a point on each side of these vertical asymptotes. So, for example, I want to know what is my y value when x is negative 2. So if I go in and I plot f of negative 2, say, well, that's going to give me 2 times a negative 2 squared over negative 2 squared minus 1. That's going to be 2 times 4. That's going to be an 8 in the numerator. And in the denominator, I would have 4 minus 1 is 3, so 8 over 3. I know 8 over 3 is greater than 2, so my point's going to be up here. I'll be able to draw in the rest of this curve towards the y-axis and up towards the value y equals 2. And then as x approaches the vertical asymptote, the y value is going to go off towards infinity. Looks something like that. And this coordinate here is our negative 2 8/3. Now, I would like to go ahead and find out the right-hand side as well. I'm expecting it to look pretty much the same. If I plug in f of 2, I know f of 2 is going to give me 2 times 2 squared over 2 squared minus 1. Well, and we see, yeah, this is still 8/3, just like the negative 2. So f of 2 and f of negative 2, both is 8/3. This is going to go down as x approaches infinity. The y value will approach the horizontal asymptote of 2. And in this direction, the y value is going to approach infinity as x approaches that vertical asymptote. I would have the point 2 8/3 here. Now, in the middle region, this is where some things can be tricky. I already know the x-intercept and the y-intercepts at 0. Probably just to figure out some more points, if I were doing this completely by hand, I would plug in 1/2 and negative 1/2, and I'd find out whether they're going up or down. My guess is that they're both down, and this looks like a negative parabola in here. I'll go ahead and use the calculator to assist with a calculation. So I go y equals, and then the numerator is 2x to the second. I'll go ahead and say that entire numerator divided by the group x squared and minus 1. Close out the denominator. Probably a good graph to see this on. I'm wondering if zoomed 4 might be better. Let's see, zoomed 4. It's just a little bit smaller graph than zoom 6. And actually, it's sufficient for this problem. Zoom 6 is going to give you a more broad picture of it, which is probably a little bit better in this circumstance. Yeah. So now I already know my y-intercept, my horizontal asymptote of 2 would be right here. And I can see that it will be approaching 2. For example, I could hit trace 9, and notice the y value is already extremely close to 2. Now, in this middle part, I see that it goes up and it hits at 0, the x-intercept at 0. It never has another x-intercept, so it's just going to go down from that point, and it's going to approach negative infinity as x approaches those asymptotes in either direction. So as x approaches negative 1 or as x approaches 1, the y values are going to go off towards negative infinity. That's why you see this region in there. Okay? Hopefully that clears it up for you. If the back of the book got something different from that, there's an error in their drawing. This should be the way that you work the problems. Let me know if you have any questions.